to all of you in this class. Up to now in the control system, we have studied the analytical method to analyze the performance of the system. That means we have studied about the transfer function approach in the time domain analysis, how to analyze the performance of the system in time domain. That means what was the first requirement there? The transfer function must have to be ready with you as well as the input combinations. Yes or no? But we cannot design the system with the transfer function approach. And we cannot see how the parameters are changing in a graphical method. Yes or no? So, the next technique, whatever you are trying to discuss here, that is the first graphical method of the control system to analyze the system as well as to design the system. And that is known as the root locus. So as it is mentioned from the name itself, root means roots of what? Roots of some particular equations. Okay. Locus. What is the meaning of the locus? Locus is nothing just the connection of the several points which will satisfy any particular mathematical equation. Okay. It is an interconnection of all the points which will satisfy the mathematical relation, which will satisfy any same mathematical relation. Then that particular curve is known as the locus. Okay. That means the points are the roots of some equation. Okay. What is that equation for which we are interested here? That we will discuss a little bit later. But the definition of the locus should be crystal clear in your mind. Locus is nothing just the connection of the points which will satisfy same mathematical equation. For example, if I want to draw the locus of all the points which will have the same distance from any particular point. Okay, that means if I am having any particular point and I want to draw the locus of all the points which will have the same distance from this point. So definitely that will be a circle. Okay, from this point if you will go anywhere, the distance will be same. Or in other words, if I will ask the locus of all the points which will have the unity distance from the x-axis. Where is the x-axis? This is the x-axis. And if you are interested in the unity distance, this will be the first line and this will be the second line. Here it is 1, here it is -1. That means all the points in these two lines will have the unity distance from this particular line. Or in other words, anybody can ask, draw the locus of all the points which will have the unity distance from the y-axis. So definitely you will draw like this. It is -1 and it is 1. It is origin. That means locus is nothing just the interconnection of all the points which will satisfy any particular mathematical equation or any particular relation they have to justify. Then that particular curve is known as the locus. So now we are interested in the connection of the points. Points are nothing, just the roots. Okay? That means what is the root locus? It is just the locus which will contain some roots. Roots of what? So ultimately here we are interested in the analysis of the system. Which is the equation which will justify the characteristic of the system or entire behavior of the system. That is known as the characteristic equation. That means these roots are nothing but the roots of the characteristic equation. Okay, so what is the root locus? Root locus is a locus which will contain all the roots of the characteristic equation. Okay, now if you want to see the variation of the roots, definitely one independent variable you have to adjust over there with which the entire root location will vary. Okay. So, because if the characteristic equation is something like this, s square plus 3s plus 2 is equals to 0. I know that the roots are s equals to -1 and -2. But here any variation of the roots you cannot see because all are the value are having a constant values 1, 3 and 2. That is where the root location are fixed. So you can never draw the locus from here. Because only 2 points are here. You cannot connect those points until you are not having any independent variable which can vary the root locations. Okay? So now if you want to see the variation of the roots with respect to any independent variable, you have to assign one independent variable. And most common independent variable in the system is known as gain k. Okay?